In this video, we are going to cover the next two cases for finding the particular solution of non-homogeneous recurrence relation. In the previous video, we have discussed these two cases where we have considered the function of the form b raised to power n and the non-homogeneous function of the form sine alpha n or the cos alpha n. But in this case, we will discuss the next case, that is when we have the polynomial on right hand side. In this case, what we need to do, here we will take the same form 1 by operator form in form of e into the polynomial. The first step in this case is replace e by 1 plus delta. So in the last video we have already done the shift operator is equal to 1 plus forward difference, that is represented by delta. So the first step in this case is replace this e by 1 plus delta. So we can write 1 upon a function of 1 plus delta into some polynomial, whatever it is given to you. After that, in the same case, we need to convert the general polynomial into the factorial polynomial. Now, what does it mean? We have covered in the last video what is the meaning of factorial polynomial. So, I will give a brief overview of that. Factorial polynomial means when we say n raised to power m. Factorial polynomial, it means we need m terms from the factorial starting from n, then n minus 1, then n minus 2, and the last term in this case is n minus m minus 1. So right now the terms are given in general polynomial. We need to convert into the factorial polynomial. So we need to learn basically three main identities. The first is whenever we have any constant, we can write n raised to power 0 form. That is a factorial form. And if we have the form n, in that case we can write it as n raised to power 1 factorial polynomial. And if we have n square, that can be written as n raised to power 2 factorial polynomial plus n raised to power 1 factorial polynomial. And n cube is written as n raised to power 3 factorial polynomial plus 3 times of n raised to power 2 factorial polynomial plus n raised to power 1 factorial polynomial. The derivation and the concept of general factorial polynomial already covered in the previous video, and the link is given in a description. After writing e with 1 plus delta and converting general polynomial into the factorial polynomial, we need to apply the binomial expansion if it is applicable. And then use the formula. What type of formulas? Basically, we will get the terms of delta into n raised to power m factorial form. Evaluate this as m into n raised to power m minus 1, and the second formula in this case is 1 by delta of n raised to power m, that is equal to n raised to power m plus 1 by m plus 1. Here these two are the factorial polynomials. Basically, when you expand this one with the help of binomial expansion, you will get the terms of this form because it is a series in terms of delta, and here we are getting a polynomial in terms of factorial form, and then we can operate delta over the each factorial term, and accordingly we can write the answer. If we are writing delta over the factorial polynomial, it acts like a differentiation, whereas 1 by delta over the factorial polynomial acts like a integration. Although these are not the simple terms, they are basically a factorial polynomial. At last, we have created a factorial polynomial in the step 1. So we need to go back to the general polynomial, and in that case you can use this formula. So we need to follow these 4 steps to find the particular solution in the case of polynomial. The case 4 is whenever we have polynomial into some b raised to power n form, where b is a constant. It's like we have 2 raised to power n into n square, or we have 10 raised to power n cube plus 3 raised to power n square. So whenever we have such forms, we can move to the case number 4. Here we have constant raised to power n into some polynomial. In this case, what we need to do, firstly we will operate b raised to power n over the operator form. So the role of b raised to power n is just replace e with b times of e and take this b raised to power n outside. Means constant raised to power n we will take extremely on the left side, but by replacing e with b into e, and this polynomial as it is. Now this is the case 3 where we just have the polynomial. Then we need to repeat the same procedure, that e is get converted into 1 plus delta, write this into the factorial form, and then expand this with binomial expansion and then simplify it. Now the point is, what important binomial expansions are required in this case? The first expansion we are writing as a journal, it is like 1 minus x raised to power minus n. This expression is equal to 1 plus n into x plus n into n plus 1 by 2 factorial into x square plus, then we will take the three terms, that is n, n plus 1, n plus 2 divided by 3 factorial, x raised to power 3. Next term is, we will take the four terms as n into n plus 1, n plus 2, n plus 3 divided by 4 factorial, x raised to power 4, and so on. So this type of series you will get from this case. Now suppose the value of n is equal to 1. What we have in that case? In that case, we are getting it as 1 plus x. When you simplify this, you will get again 1. So we simply get x square plus x cube plus x raised to power 4 plus x raised to power 5 and so on. So here we have the negative negative, then all the terms are in a positive. Moreover, the coefficients are 1, 1, 1, 1. Similarly, we can expand 1 plus x raised to power minus 1. It is a positive negative. So same series is there but with the alternative sign. So we can write in this case 1 minus x plus x square minus x cube plus x raised to power 4 minus x raised to power 5 and so on. For the next case, when we have 1 minus x raised to power minus 2, negative negative is all signs are positive. So we can write 1 plus, it is 2. Here we can write directly n, 2x. Simplify this, you will get 3x square, then 4x cube, then 5x raised to power 4, so on. So here we are getting coefficient as the natural number 1, 2, 3, 4, 5, 6, 7, 8 and so on. In the same case, if we are replace this negative sign with a plus, we will get the alternative sign from this series. So we can write 1 minus 2x plus 3x square minus 4x cube plus 5x raised to power 4 and so on. For the next case, the series is again with the positive sign because it contains negative here, negative here. So we have in this case as 1 plus 3x plus 6x square. The next term is not 9. As we are getting a pattern as 1, 3, 6, it is not always a multiple of a 3. So here we are not getting 9. We have in this case as 10x raised to power 3. And the next term is a 15x raised to power 4. So this is very important. This is not a 9. Even you can check it from here. When you put n is equal to 3, we have 3 into 4 into 5 by 3 factorial, that is the 2 into 3. So this 3 is get cancelled with this one. This is get 2. So 2 into 5 is 10. And the same is applicable in this case. From here, This is same 3, 4, 5 by into 6 by 2, 3, 4. This 4 is get cancelled with 4, 3 with 3. This is 3. So 5 into 3 is 15. For this case, 1 plus x raised to power minus 3, same series but with the alternative sign. So we have 1 minus 3x plus 6x square minus 10x cube plus 15x raised to power 4 and so on. So these are the few binomial expansion we required in this case. Now let's understand these cases with the help of examples. Here we have the first question as we need to solve this recurrence relation. In this recurrence relation, we have the polynomial form as a non-homogeneous function, that is n square minus 4n plus 5. The first step is same, take all the sequential term on one side. So from here we can write an minus 2 is equal to n square minus 4n plus 5. In the next step, we need to remove the negative index if it contains. Here we have an, here we have n minus 2. So we need to shift this index over the n. For that, we need to apply the shift operator. So apply shift operator twice. So we can write in this case n is shifted to n plus 2. So we can write here as an plus 2 minus an plus 2 minus 2. This is equal to n plus 2 whole square minus 4 times of n plus 2 plus 5. This implies an plus 2 minus an is equal to, expand this, we have n square plus 4 of n plus 4 minus 4n minus 8 plus 5. This 4n is get cancelled with this one. We have n square minus 4 plus 5, that is plus 1. On left side, we can write this in form of e, that is e square of an minus an. Because in this case, an is shifted 2 times and that's why we are getting an plus 2. This implies e square minus 1 into an is equal to n square plus 1. From here we have the characteristic equation as the characteristic equation is equal to e square minus 1 is equal to 0. And in form of r we can write r square minus 1 is equal to 0. So this implies the value of r is plus minus 1. So homogeneous solution for this recurrence relation is first constant first root raised to power n plus second constant second root raised to power n. Or we can write from here c1 plus c2 minus 1 raised to power n. This is the for homogeneous solution. But for non-homogeneous, we will take this operator form in denominator. So we can write an is equal to 1 upon e square minus 1 n square plus 1. So this bracket is very important because this operator is going to multiply with both the terms. From here, how to proceed? First step is replace e by 1 plus delta and general polynomial into factorial polynomial. Now what is the value of n square in form of factorial polynomial? That is n raised to power 2 factorial polynomial plus n raised to power 1 factorial polynomial. For 1, that is n raised to power 0. So n square plus 1 in form of factorial polynomial is this. So we can write in this case 1 upon 1 plus delta whole square minus 1, and in place of n square plus 1 we can write its factorial polynomial as n raised to power 2 factorial polynomial plus n raised to power 1 factorial polynomial plus n raised to power 0 factorial polynomial. Simplify this denominator term. When you simplify this, we have 1 plus delta whole square minus 1. This is equal to 1 plus 2 delta plus delta square minus 1. So this minus 1 plus 1 is get cancelled. We have 2 times of delta plus delta square. So in place of this, we can write 1 upon 2 delta plus delta square, and this function I am writing as small f. Now we need to expand this. For that we will use the binomial expansion, and for binomial expansion we need 1 plus x raised to power minus 1 form or 1 minus x raised to power minus 1 form. As you can observe, this is in a power 1. So we will go with either plus x form or minus x form, but we need to create a 1. So for that what we can do, we can take the lowest power of delta outside along with its coefficient. So in this case the lowest power is delta. So we will take this delta outside along with its coefficient. If it contains negative sign, also take that outside. But right now it is a positive, so we can write 2 delta outside, 1 plus delta square by 2 delta. This is equal to 2 delta 1 plus delta by 2. So in place of this, we can write this. So we have in this case 1 upon 2 delta 1 plus delta by 2 into this function as it is. Now take this term in the numerator. We have 1 upon 2 delta 1 plus delta by 2 power minus 1 into function. Expand this 1 upon 2 delta as it is. The expansion for this case is equal to what? So here we have power 1. So coefficients are 1, 1, 1, 1, and signs are opposite because it is plus and it is negative. So we can write 1 minus x plus x square minus x cube and so on. So here x is delta by 2. So replace this x with delta by 2. We have 1 minus delta by 2 plus x square means delta square by 2 square minus x cube, that is delta cube by 2 cube and so on, and we have this function as it is. In the next step what we can do, we will keep this 1 by 2 delta as it is. Multiply this function with each and every term. We have f minus delta by 2 into f plus delta square by 2 square into f minus delta cube by 2 cube into f. Continue. Now what is the value of f? F is basically, it is n raised to power 2 factorial polynomial plus n raised to power 1 factorial polynomial plus n raised to power 0 factorial polynomial. In the next step we need to substitute the value of f here, but for that we need delta of f. When you apply delta on the function f, means it is kind of derivative, but it is right now in a polynomial form. So we can write its derivative as 2 raised to power n, but we cannot write simply n, we need to write in a factorial form n1 plus derivative of simple n, that is 1, and 1 cannot be written directly, we can write it as n raised to power 0 plus n raised to power 0 is 1 and 1 derivative is 0, so this term is 0. Similarly calculate delta square f, kind of a derivative. Its derivative is 2 constant, n ka derivative is 1, but we can write n raised to power 0 plus this is constant and constant derivative is 0. Next is delta q of f. So again take its derivative, that is 0. With the help of this you can analyze We can take this expansion till the time we have maximum power of n. Like in this case, maximum power of n is 2. So we can keep delta till delta square because rest of the terms becomes 0. So clearly this term is 0, its next term is 0, even all other terms are 0. In place of this, we can substitute the value. We can write 1 upon 2 delta. Function is n raised to power 2 plus n raised to power 1 plus n raised to power 0 minus 1 by 2 as it is the value of delta f, that is 2n1 plus n0. In place of this is plus 1 by 2 square is 4, delta square f is 2 of n0 and all other terms are zeros. From here we can write 1 upon 2 delta n raised to power 2 factorial polynomial plus what is the coefficient of n raised to power 1 factorial. This is 1. Here we are getting a minus 1 because this 2 is get cancelled with 2 with the negative sign, it will be 0 plus n raised to power 0 factorial polynomial coefficient is 1 minus 1 by 2. Here we have plus 1 by 2. This is equal to 1 upon 2 delta n raised to power 2 factorial polynomial. This term is 0. Here minus 1 by 2 plus 1 by 2 is get cancelled. Simply we have n raised to power 0 factorial polynomial. 1 by 2. Now 1 by delta is kind of an integration. Now what is the integration of this form? N square, that is n cube by 3. So in this case we will write n raised to power 3 factorial polynomial divided by 3 plus constant integration is n. So in this case we can write n raised to power 1 factorial polynomial by 1. This is the third step. Now we need to write the last step where we need to convert this factorial polynomial into general polynomial, that is as equal to 1 by 2. What is the general form of n raised to power 3 factorial polynomial? It means we need 3 terms from the factorial form, that is n, n minus 1, n minus 2 divided by 3 plus what is the general form of factorial polynomial with power 1? That is n by 1. And this is the final answer in this case. The next question we have, solve this recurrence relation. Again we have considered the non-homogeneous case as polynomial. The step 1 is take all the sequential term on the one side and try to remove the negative index if it contains. Like in this case, we have n minus 1, so we will apply the shift operator once. It means index n is shifted to n plus 1. So we can write a n plus 1 minus 3 times of a n is equal to n plus 1 plus 1. From here we can write this is e of en minus 3 times of en is equal to n plus 2. Simplified form from here we have e minus 3 into en is equal to n plus 2. So for the homogeneous case we need the characteristic equation. The characteristic equation is e minus 3 is equal to 0, or in form of r, this is r minus 3 is equal to 0 implies r is equal to 3. And the homogeneous solution in this case is equal to C1 3 raised to power n. For particular solution, we will take the operator form on next side. That is, from here we can write en is equal to 1 upon e minus 3 into n plus 2. The first step is replace e with 1 plus delta and Write n plus 2 in a factorial polynomial. What is a factorial polynomial of this? So n is replaced by n raised to power 1 plus 2 times of n raised to power 0 factorial polynomial. Plug in these values here. We have 1 upon 1 plus delta minus 3, and n plus 2 is n raised to power 1 factorial polynomial plus 2 times of n raised to power 0 factorial polynomial. This is equal to 1 upon delta minus 2 n raised to power 1 factorial polynomial plus 2 times of n raised to power 0 factorial polynomial. Now we need to take this term in a numerator, but before that we need to convert into 1 plus or 1 minus x form. To convert into 1 plus x form or 1 minus x form, we need to take one thing outside. Always start from the lowest power of delta. It contains delta raised to power 1 and here delta raised to power 0. So take this term outside along with its negative sign. So we will write this as delta minus 2 is equal to minus 2 plus delta minus 2 outside, that is 1 plus delta by minus 2. This is equal to minus 2 1 minus delta by 2. So replace this one with this. We have 1 upon minus 2 1 minus delta by 2 into this function, let it be a f. This is equal to minus 1 by 2 as it is. Take this term in the numerator. It is 1 minus delta by 2 raised to power minus 1, and this function as it is. This is further is equal to minus 1 by 2. Expand this. So it is 1 plus delta by 2 plus delta square by 2 square plus delta cube by 2 cube and so on into f. How we are getting this one? It is an expansion of 1 minus x raised to power minus 1. This is equal to 1 plus x square plus x cube. Continue this. So in this case the value of x is delta by 2. Now simply multiply this. This is equal to minus 1 by 2 into f plus delta of f by 2 plus delta square f by 2 square. Now the point is, do we need these terms or not? As from here the maximum power of n is 1. So there is no need to take delta square as well as delta cube. In the next step they are getting a zeros. Now how it is getting 0? Here we have taken f is equal to n raised to power 1 plus 2 into n raised to power 0 factorial polynomial. When you apply the delta over here, it is like derivative. Its derivative is constant and constant is represented by n raised to power 0 plus 2 into constant derivative is 0. Similarly, take delta square of f. Now n raised to power 0 is constant and constant derivative is 0. Obviously, if delta square f is 0, so delta cube f is also 0. So in that case, this term is 0, even next terms are 0. From here, we can just simply put the values of f and delta of f. So we can write n raised to power 1 factorial polynomial plus double of n raised to power 0 factorial polynomial plus 1 by 2 delta f is replaced by n raised to power 0 factorial polynomial. Simplify this. This is minus 1 by 2 n raised to power 1 factorial polynomial plus this is equal to 5 by 2 n raised to power 0 factorial polynomial. And the last step is convert back this factorial polynomial into general one. So this is minus 1 by 2 as it is. N raised to power 1 factorial polynomial means we need one term from the factorial, that is n, plus 5 by 2 n raised to power 0 factorial polynomial means we don't need any value from there. So we will simply put 1. So that is the final particular solution in this case. And the general solution in this case is equal to homogeneous solution plus particular solution. Taking next example, we need to solve this recurrence relation. So first step is take all the sequential term on the left side. We have an minus 4 times of an minus 1 plus 4 an minus 2 is equal to 2 raised to power n minus 1 n cube. Then remove this negative index. So we need to apply shift operator twice because here we are getting n minus 2. So when you replace n with n plus 2, what we have? This is a n plus 2 minus 4 times of a n plus 2 minus 1 plus 4 times of a n plus 2 minus 2 is equal to 2 raised to power n plus 2 minus 1. Here n plus 2 raised to power 3. Now is this is the case of polynomial? No. It is polynomial into something is here, that is constant raised to power n form. So basically this is the case number 4. So in this case what we need to do, first we will write the homogeneous solution. So from here first we will simplify this. This is a n plus 2 minus 4 of a n plus 1 plus 4 times of an is equal to 2 raised to power n plus 1 into n plus 2 raised to power 3. Write in operator form. This is e square as it shifted the an with 2 steps minus 4 times of e plus no shifting. So we will not write e here. So simply we can take in this form. This is equal to 2 raised to power n plus 1 n plus 2 raised to power 3. From here the characteristic equation is e square minus 4e plus 4 is equal to 0. And in terms of r, it is r square minus 4r plus 4 is equal to 0. Now what are the roots in this case? That is 2 and 2. Both are real and the equal roots. So homogeneous solution in this case is equal to C1 first root raised to power n, C2 second root raised to power n into n because both are same. Or we can write it as C1 plus C2 into n 2 raised to power n. Now for the particular solution, we can write it as 1 upon e square minus 4e plus 4. On right hand side we have 2 raised to power n plus 1 n plus 2 raised to power 3. So whenever we have the case b raised to power n into some polynomial, the first step is always deal with b raised to power n. So with the help of this, we will replace e by b into e. In short, first we will deal with 2 raised to power n plus 1 and then we will move to the polynomial. And for this case, when they are in a product form, we can replace e with b into e. Now before moving to that, also observe that it has a 2 roots, that is 2 and 2. It means we can write it in a factor form. That will give you the more easiest form, that is e minus 2 into e minus 2. Here 2 raised to power n plus 1, n plus 2 raised to power 3. That can be also written as 1 upon e minus 2 whole square 2 raised to power n plus 1, n plus 2 raised to power 3. Now the calculation is more easy if we substitute e by b into e for dealing with this case. So we can write in this case, this is 2 raised to power n plus 1, and e is replaced by 2 into e minus 2 whole square, and this polynomial is as it is. So in this step, when we have the product form, first replace e with b into e, and then we will move towards the polynomial case. Simplify this. This is as equal to 2 raised to power n plus 1 outside. Because we are done with this case, we just need to figure out for the polynomial now. This is as equal to, take 2 outside, we will get a 2 square outside, 1 upon e minus 1 whole square. This is n plus 2 raised to power 3. Simplify this. This is equal to, adjust this power here. This is 2 raised to power n plus 2 minus 2. And we can write here as 1 upon e minus 1 whole square as it is. Expand this. What is the value of a plus b whole cube? This is equal to a cube plus b cube plus 3a square b plus 3ab square. So we can write it is n cube plus 8 plus 6n square plus 12n. Now we can move to the case number 3 because it is like a polynomial only. So for that, first we need to replace e with 1 plus delta. When you put e is equal to 1 plus delta, e minus 1 is equal to simply delta, and taking square on both sides, it will give you delta square. So here we can write 2 raised to power n minus 1, 1 upon delta square. Now what is the value of this polynomial in form of factorial? Here we have n cube plus 8 plus 6n square plus 12n. What is the value of n cube in a factorial polynomial? That is n raised to power 3 factorial polynomial plus 3 times of n raised to power 2 factorial polynomial plus n raised to power 1 factorial polynomial plus. For constant, we can write n raised to power 0 factorial polynomial plus 6 times of n square is written as n raised to power 2 factorial polynomial plus n raised to power 1 factorial polynomial plus 12 n raised to power 1 factorial polynomial. This is as equal to, now collect the coefficient. The coefficient of n raised to power 3 factorial polynomial is 1 plus, for n raised to power 2 factorial polynomial, it has 3. Here we have 6 into 1, that is 6 plus n raised to power 1 factorial polynomial coefficient. Here we have 1 plus 6 plus 12 plus 8 into n raised to power 0 factorial polynomial. Simplify this. This is n raised to power 3 factorial polynomial plus 9 times of n raised to power 2 factorial polynomial plus 19 times of n raised to power 1 factorial polynomial plus 8 times of n raised to power 0 factorial polynomial. So here we have substitute the factorial form of this general polynomial. Now we have 1 by delta. 1 by delta is like a integration. So what we need to do? So we will do the kind of a integration 2 times. So 1 by delta 1 is as it is. Take the integration of this. What is the integration of n cube? That is n raised to power 4 by 4. But here we write n raised to power 4 factorial by 4 plus this 9 as it is. What is the integration of n square? That is n cube by 3. So here we write n raised to power 3 factorial polynomial by 3 plus 19. Here we can write n square, that is n raised to power 2 factorial polynomial by 2 plus constant integration is x. But here we are dealing with n. But n is replaced by n raised to power 1 factorial polynomial by 1. This is the value of simply 1 by delta. Moreover, we have 1 by delta more here. So again we need to take its integration. So we can write 2 raised to power n minus 1. Take its integration, 1 by 4 outside. This is n raised to power 5 factorial polynomial by 5 plus 9 by 3 is 3. N raised to power 3 factorial polynomial is get converted into n raised to power 4 by 4 plus 19 by 2 as it is. N raised to power 2 factorial polynomial is get converted into n raised to power 3 factorial polynomial by 3 by operating 1 by delta plus 8 times of n raised to power 2 factorial polynomial by 2. And the last step is rewrite this factorial polynomial into the general form. So we can write 2 raised to power n minus 1 as it is. 1 by 4 into 5, that is 1 by 20. N raised to power 5 factorial polynomial is equal to, we need 5 terms from the factorial, that is n minus 1, n minus 2, n minus 3, n minus 4 plus 3 by 4. N raised to power 4 factorial means we need 4 terms from the factorial. That is, first term is n, second term is n minus 1, next term is n minus 2, and the fourth term is n minus 3 plus 19 by 2 into 3, that is 6. N raised to power 3 factorial polynomial is n minus 1, n minus 2. And the next term is plus 4, and this is replaced by n minus 1, and this is the final particular solution in this case.